Okay, these are some problems that you'll bump into on tomorrow's Unit 5 chemistry test. So let's go through some of them. First one says, which is the closest number of grams to in 9.03 times 10 to the 23rd atoms of fluorine. So always start with what you're given, which is 9.03 times 10 to the 23rd atoms. And you want to get from atoms all the way down to grams, which is 2 steps. The molar mass of, well, not yet. So you need first to divide by Avogadro's number. So 1 mole of anything is 6.02 times 10 to the 23rd of that something. And then you want to get from moles into grams. And so you multiply by the molar mass of fluorine, which is 19. And in your calculator, you would do 9.03 times 10 to the 23rd times 19 divided by 6.02 times 10 to the 23rd. And I get 28.5 for your answer. And since it's grams, you should label it with a G, grams of fluorine. Next one, what's the closest number of grams in 2 moles of sulfur dioxide gas? So again, start with what you're given, 2 moles sulfur dioxide. So 2 moles SO2 is sulfur dioxide. And then you want to get from moles to grams, so you multiply by the molar mass of sulfur dioxide. So SO2 is 32 plus 16 times 2 for oxygen equals 64. So you'd have 64 on top here, 1 mole on bottom. And you'd have 2 times 64, which is what, 128? So your answer would be 128 grams of SO2. Next one, you've got which is considered the molecular formula for propane. This is the formula for propane, so what's the molecular formula? And molecular formula means regular formula, so it's C3H8. No change there. Same with this problem, which is considered the molecular formula for methane, CH4, same situation. That is the molecular formula for methane. If it's formula and molecular formula mean the same thing, so CH4 for methane. And then a slightly longer problem here at the end. What's the molecular formula of a compound with the following composition? It's got all these numbers here for composition for percents and a molar mass. This is the longest kind of problem that you would see tomorrow. So the first thing is 51.28. You want to get all these grams or percents into grams. It's for carbon, 9.4 grams of hydrogen, 27.35 grams of oxygen, and 11.97 grams of nitrogen. Then convert them all into moles by dividing by molar mass. So carbon is 12, hydrogen is 1, oxygen is 16, and nitrogen is 14. And you're going to get 4 decimals in this case. So 51.28 divided by 12 equals 4.273. And then this is obviously going to be 9.4. And then for oxygen, 27.35 divided by 16 equals 1.709. And then for nitrogen, 11.97 divided by 14 equals 0.855. Now divide all of them by the smallest number, which is 0.855. Sorry. Okay, so let's start at the top there. 4.273 divided by 0.855 equals about 5. And then 9.4 divided by 0.855 equals 10.99, which is 11. 1.709 divided by 8.55 equals, 1.709 divided by 0.855 equals 1.99 or 2. And this obviously equals 1. This is the empirical formula. So you get C5H11O2N. Okay, that's the empirical formula, not what we want. We want the molecular formula. So now we have to add up this molar mass, like you regularly would for the molar mass. So that would be 12 times 5 for oxygen. For carbon, for hydrogen is 11. For oxygen is 16 times 2. And for nitrogen, it's 14. So that equals 12 times 5 plus 11 plus 16 times 2 plus 14, 117. And then you take this number given to you in the problem, which is this 234, and divide by this 117 you just found. So 234 divided by 117 equals 2. And that's the number you multiply back into this formula to figure out what its true molecular formula is. So it becomes C10, H22O4, and 2. And there is your molecular formula. Good luck studying tonight. Yay! Cancel all your plans. Bye!